Hello, this is mathstutor4u.com with another video tutorial explaining how to complete the required proofs specified in the CCA specification for the learning outcomes for Unit A2 Pure Mathematics. The specification shown on the screen is available on the CA website. Let's consider the sequence 4, 7, 10, 13, 16, and so on. The first term is denoted A, and in our case is equal to 4. And the common difference is 3. This series is called an arithmetic progression. In more general terms, we can write the arithmetic progression as the first term is A, the second term is A plus D, the third term is A plus 2D, the fourth term is A plus 3D, and so on. The nth term is our last term. Let's consider the coefficients in the front of the common difference. For the first term, it's plus 0d. We have the coefficients are 0, 1, 2, 3. And the formula connecting them, it's n minus 1. So, for the nth term, denoted un, which is our last term, is equal, instead of the numbers now for the nth term, just put first term plus n minus 1 d. So now this is the formula for the nth term, or the last term of an arithmetic series. Let's find the sum of the first n term of an arithmetic progression. The Sn is equal to the first term plus a plus d plus a plus 2d, and so on until the last term. The term prior to the last term, it's L minus D and L minus 2D. Now, rewriting this one in the reverse order. So Sn is equal, so the last term, it will become the first term, so that will be L plus L minus D plus L minus 2D, and then A plus 2D, A minus D plus A. If we add them, we have 2Sn is equal A plus L, and then the difference there will cancel, that will be A plus L. The difference there will cancel again, A plus L. And then the same in here, A plus L, and then A plus L plus A plus L. So if you can see now, we've got n A plus L terms. So we can write 2Sn is equal to n A plus L. So Sn is equal to half n A plus L. So that is the formula for the nth term. The last term, as we said before, here, the un, which is our last term, is equal to A plus n minus 1 d. Let's substitute in here. So we have Sn is equal to half n A plus n minus 1 d. So Sn is equal to half n times 2a plus n minus 1 d. That is the formula of an arithmetic sequence. Now let's consider another sequence. 2, 6, 18, 54, and so on. Each term is obtained by multiplying the previous term by 3. This type of sequence is called a geometric series, where the first term A is equal to 2 and the ratio is 3. So in more general terms, we can write a geometric series as the first term A plus AR plus AR to the power of 2 plus AR to the power of 3, and so on. So they are the first, second, third, fourth, and so on up to the AR to the power of n minus 1, and that is the nth term. The sum of all those terms is equal to a plus AR plus AR squared plus AR cubed and plus AR to the power of n minus 1. If we multiply the both sides of this equation by R, we obtain R Sn is equal, that will be, multiply the first term, that multiplied it will be AR plus AR squared, so that will go there, that will go there, plus AR cubed, so which is that, multiplied by R, plus AR to the power of n. If you multiply that by R, it becomes a to the power of n. Now, if we subtract those, we obtain Sn minus R Sn is equal, if we subtract them, that means that the terms AR minus AR will cancel, so these terms will always cancel. And this term will cancel the previous term, which was a to the power of Rn minus 1 there, so they will cancel. So on the right hand side, we're going to have a minus AR to the power of n. Let's factorize Sn multiplied by 1 minus R is equal to a times 1 minus R to the power of n. Let's divide. Sn is equal to a times 1 minus R to the power of n over 1 minus R. And this is the formula for the geometric series. There is a special case in here. With R smaller than 1, R to the power of n tends to 0 as n tends to infinity. So therefore, the sum of nth term is equal to a times 1 minus 0 over 1 minus R. So that's equal to a over 1 minus R. So this expression gives the sum to infinity of the geometric series, with the first term being a and the R. Please follow me for more quality tutorials from mathstutor4u.com.